Hey, another fun-filled day with the law of cosines. Oh my goodness, this looks really different. We don't know any of the angles. So what should we find first? Well, we're going to have to use the law of cosines. Right, because we don't know any angle at all, so we can't not set up a proportion with any ratios for sine. That's right. We need to find angle B first. Thank you. Great job. Great job. Oh, somebody wants to know why angle B? Why should we look for angle B first? Notice that angle B will be the largest angle because it's across from the longest side, right? The longest side has a length of 6, and that's opposite angle B, right? So, for just a moment, let's look at what happens when we're greater than 90 and less than 90. Right? The sine function, if we're 1 degree over 90 or 1 degree under 90, right? Notice we get the exact same value off a calculator. 1 degree more than 90, 1 degree less than 90, identical. So if I do an inverse sine, well, that value, how do I know if it's 89 or 91? Look at cosine though. Cosine of 89 comes out positive. That's 1 less than 90 degrees, of course. But if I'm 1 more than 90 degrees, cosine comes out negative. With the sine function, I cannot tell if I'm greater than 90 or less than 90. But with the cosine function, I can tell. So if I don't know any of the angles, and there's a possibility that one of them might be more than 90, I need to use cosine to catch that one. Right? So it's imperative that if one of the angles might be more than 90, I use the law of cosines to catch that, because after we use the law of cosines, we're going to want to switch back the law of sines. And law of sines won't catch it if it's more than 90 degrees. All right? Cosine is our friend. It'll never lead us astray, unlike sine. All right? So if one of the angles is greater than 90 degrees, also known as an obtuse angle, the law of sines is not going to let us know. So the largest angle, if it could possibly be greater than 90 degrees, use the law of cosines. All right, so let's get back to that example. All right, what should we find first? Obviously, we now know we need to go for the largest angle, which is B. So I will need B squared equals A squared plus C squared minus 2AC cosine B. We know lowercase a, b, and c. We can plug those in, calculate angle B. All right? 6 squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of B. All right? 6 times 6 is 36. 4 times 4 is 16. 5 times 5 is 25. 2 times 4 is 8. And then 8 times 5 made 40. 16 plus 25 is 41. Again, don't be silly. Don't try to do 41 take away 40. I know it looks tempting, but notice that 40 is being multiplied by cosine of B. I cannot do 41 take away 40, as tempting as it is. Instead, I need to isolate the variable, so we got to subtract 41 from each side. Now, the opposite of multiplying by negative 40 will be dividing by negative 40. And I get positive 1/8, or if I want to use decimals, 0.125. And it's like, hey, I don't want the cosine of angle B. I just want angle B. Arc cosine, right? Inverse cosine. I'm like, it's a cute 82.8. And that, of course, will be the largest of the three angles because it's across from the largest side. So the other two angles will be less than 82.8. We can switch back to the law of sines now because I know both sine of B and B. Right? Plug in the three values I don't know. All right, and you see why we did law of sine first, because using law of cosine, we keep reverting back to using the law of sines. All right, you say, hey, about 41.4. And now we're on easy street. We know two angles. We know the three angles must add up to 180. And so we can quickly deduce that the third angle has to be 55.8. That's scary music. Is there something scary in the ocean? Uh-oh. Something scary is out there in the ocean. Oh yeah, that was probably the first real original blockbuster movie that had lines wrapping around the theater. Back in the good old days where you actually had to wait in line to buy a ticket and then go wait in another line to get inside the movie theater. Cows. Oh, what a thriller that was.